Previously on the Aruba switching story, we've learned about the Edge Services platform and how Aruba switching fits into the unified infrastructure as part of ESP. We've also learned from Steve Bartlett and Kamal Kodra on how to provision a data center with Aruba Fabric Composer. Next, we're going to hear from Kamal and Steve on how to continually use the guided workflows to configure the data center.
Hey, Justin, thanks for that. So I guess it's now to the underlay.
Well, yes, yes, you've got that one right. Underlay is the next one that we need to configure. Now we've configured our IP addressing on our leaf and spine connectivity. We just select on underlay. And here we are. It's defaulted to the underlay tab. I just select add and off we go. And I'm going to call it a fancy name like underlay. And I've got two options, OSPF or EBGP. I'm going to stick with OSPF. Happy with that. Transit VLAN. So the transit VLAN is there to give us neighbor adjacency between the top of rack leaf 1A and leaf 1B, for instance. Give us a layer 3 neighbor adjacency so that we can synchronize our routing table, excuse me. And pre-populated values here, all best practice. I've got an authentication type that I can use, but I'm not going to go with that. I'm just going to go with this default values here. And that's it. And I press apply, and that's off. That's going off now, creating the loopback address or using the loopback address that's already been created as part of the VSX pairs. And that was going to configure our OSPF configuration. That's done for our underlay. So that's now configured OSPF on each leaf switch and each spine switch and formed our OSPF adjacencies.
Wow, Steve, that seemed really quick and simple to deploy. So I guess now you've done the underlay, you now need to start looking at the overlay, right?
Yep, and that's all we do. Yeah, we configure overlay, we select on the overlay tab. Again, we just select add, and then we get the wizard up. And we've got a few inputs here, but they're not complicated at all. So we've got a couple of options, dual ASN, or multi-ASN. So we're going to go for the dual ASN. That gives a common AS number for the spine. I'm going to use 64512 for that. And leaf ASN number, I'm going to use 65001 for that there. So each leaf will have the same autonomous system number. The spine will have 64512 as its autonomous system number. If we used a multi-ASN, all that would do is that we'll get the option for the unique ASN number for the spines and a separate and discrete AS number for each leaf pair, but we're going to go for this dual ASN number option. And this is the 2-byte format that we're using. It's easier to read, so we'll go with that. We don't need the extended 4-byte format at all. And we've got an IP address range to give it. So I'm going to give it a /24 sub 192.168.10. Hang on, I need to put the right format in for that. 3 times a charm. These keep alive hold down timers are pre-populated, best practice, so we're all good with those. Again, we get a summary and then we press apply. So now we're configuring our overlay with EBGP and EVPNs being set up, along with our VXLAN VTEP ready for the next step in our configuration. So are you happy with that, Kamal?
Yeah, I'm getting it now. It's taking us through step by step on that guided setup. I'm fully understanding all the steps. And for me, I can see it looks like in the guided setup, the last part is to configure the EVPN.
Yes, that's the final step. You're right. That's all we need to do now is create the EVPN configuration. And this is where we get the option of creating our VLAN and mapping it to a virtual network identifier that's then a map to our VTEP, which we created with the overlay. So all we need to do now is kick it off by selecting next. I'm going to call it a I'm going to just create, need to create VLAN 101. So let's do that. I'm only creating one VLAN, and I'm going to call it give it that name. I'm going to give it VLAN 101 is the one we want to for our facial recognition app. And I need to give it a base layer 2 VNI, which I can really give any number I like, but somewhere in here I'm going to give it 101 just to identify it. It's too many noughts. Again, we get system and MAC address range pre-populated. That's part of our best practice values. And the AS number we're going to use is the top of rack leaf for that. And then we have our summary again, and I just select apply. And now that is creating our VLAN, mapping it to a virtual network identifier, which is associated with our VTEP, and it's done that on every top of rack switch leaf pair. So we've now effectively got a spine and leaf fabric. So are you happy with that, Kamal, so far?
Right, yeah, totally, Steve. But I've got another question for you. So we've done the guided setup, and we've set up the spine and leaf, underlay, overlay, control plane effectively. But one thing that seems to be missing to me is, our application needs to be hitting some sort of default gateway in the data center, right? This facial recognition app. So could you tell us about that? There must be something to do here.
Oh, indeed, yes. So we finished our guided setup. We've got a spine and leaf fabric effectively ready to go. You're right. And we do need something else. The next step is just outside the guided setup. So we've got to create a gateway for our top of rack switches for a VLAN. And then, of course, then our application can break out from its subnet. So all we need to do is go into configuration, routing, and select VRF. Everything's currently in the default VRF, so that's where we're going to do the configuration. And on that, all I do is select it and then select IP interfaces. Very easy. And it will give me a list, there it is, of all the IP interfaces that it's already got on all the switches. So we're under the IP interface tab. I just select add, and I'm just going to add an IP interface. And here we get some options. Now, I don't want a switch virtual interface. If I do a click on here, I get a drop down. The one I'm after is a distributed SVI. So I'm going to select that. And it's a VLAN 101, which we're looking after. Now I need to give it an address range, sorry, an address block. And I need to give it a gateway address. 68.1.254 and a MAC address. I need to type this in. It's a little bit manual, but it's very quick to do. Let's do that. And then I give it now what's happened here? It's not right. 168. Switch address range. Now this is just giving an IP, dedicated IP interface for each gateway on top of each top of rack switch. It's going to use this active gateway, but there's a physical an IP interface on the interface itself. So I just need to give it a range to use. I'm going to give it to 192.168.101.204. And effectively, so I've got 4 addresses there, 1 for each top of rack switch. And now we are good to go. I can give it a name, VLAN 101 DSVI. Yep, I'm good with that. Don't need the description. Then we get a summary, 101.254. It's going to use that MAC address and push that down to every top of rack switch. And the IP interface range for those 4 gateways is going to be that 200 to 204. In fact, there's one too many there. Just going to take them out of that pool. So now we're going to create that gateway. And that's done. Now I've got it. If we looked in the CLI now, we would see that there. So are you happy with that, Kamal?
Yeah, Steve. So you've now just gone in and deployed this distributed gateway. Now, I'm not really familiar with a distributed gateway. Could you tell me a tiny bit more about this?
Yeah. So a distributed SVI, switch virtual interface, is a gateway. It's also known as an Anycast gateway. It's a gateway that resides on every leaf switch for a specific VLAN using that. And for that VLAN, we use that same gateway IP address and virtual MAC address. So the benefits are we get reduced latency for endpoint devices and reduced bandwidth costs, as traffic breakout, if we do a layer 3 lookup, is always going to be on the top of rack switch if we wanted to break out of that VLAN. And it prevents that tromboning across the network to a centralized gateway. So they're the basic fundamental benefits.
Right. Okay. Now I get that. Thanks for explaining that to me, Steve. So it seems like we've done most of the steps in terms of creating a fabric, leaf and spine. We've gone through the guided setup. We've got all the gateways. Now, I would like to see what's it actually done in terms of configuration. Could we see what it looks like now?
Yeah, of course we can. Let's just drop onto leaf 1A. Let's have a quick look. If I do a show VSX status, that's all nicely. It's configured our VSX. If I do quickly do a show run, and we can just go through some of the configuration here. We can see at the top there, we've got an EVPN configuration that we did as part of our overlay. Got a lag created as part of the VSX process, and somewhere along here we can add some interfaces as part of the leaf spine process flow. Here they go. We mentioned about a /31. That's a point-to-point link. Oh, sorry, let's keep alive. There should be some others. Here we are to the spine in /31 inner IP OSPF areas as part of our underlay configuration that we did. VTEP is configured here as part of our EVPN configuration. And at the very end, we've got, obviously, this is our underlay part of our configuration. We've got our overlay configuration here with EVPN extensions. And if we do a show IP OSPF neighbors, we'll have 3 full neighbor adjacencies, 2 to the spine and 1 to our adjacent leaf node on leaf 1B. And if I do a show BGP, layer 2 VPN, EVPN summary, yeah, we've got a EVPN connectivity model established across our fabric. So now we're raring to go, I think.
Steve, you mentioned the Composer has integrations and third-party visualizations. Can you show us this, and how does this also benefit customers?
Yeah, certainly, Kamal. So the easiest thing is to actually show it, to explain it. So if we go into configurations, integrations, and these are all the integrations that we have today. But the one we're interested in right now is the VMware vSphere. So let's go into that. And let's add this integration. So I'm going to add VMware vSphere. I'm going to call it vSphere. I've just got to give it a login ID to obviously define the host of VMware vSphere, which I'm going to give it this IP address that we need to log into vCenter, and a administrator account. I'm going to type in, we can do a read-only account because it's only a pool. It's very important to note that, because there's no danger of any overwrites from the Composer because it's a read-only activity, because it's pulling the information in. And I get the option to validate this. So I'm just going to check that looks good. And it's in the next step that we get this automated provisioning of VLANs. So this range here, basically what it means on the range, if I specify a range here, say 1 to 200, this means that any VLAN that's already provisioned in vSphere, and if there's a connectivity model down into the top of rack switch from a vSwitch, then the Fabric Composer will configure those VLANs that it discovers going down into the top of rack switch, and we should be able to see that. And I'm going to select 1 to 200 as an example, for instance. And I select next. I'm going to select discovery protocols. I then get the summary again, which let's have a quick look. 1 to 200. Yeah, I'm good with that. And I'm going to press apply. And now what the composer is now doing is pulling the information from vCenter, and all the rich detail that it finds, it will give us a visualization. So if we pop into a visualization and select hosts, we should get, here it's just loading the information up for us. Here we go. So now we get all the ESX switching that is discovered, the host that is discovered. And you can see now we've got our CEC facial recognition app that's sitting on subnet 192.168.101 with an IP address of .200. And we can trace this all the way down. You can see that it's now connecting to a port group called FaceApp VM Direct, and it's in VLAN 101. It connects to vSwitch 14, and we've got details of the VM NIC, and it's connected to VMNet 4 at 10 gig, and it's going down to our top of rack switch. And on here, we can see that the link's up, it's 10 gig, it's that's the port type in SFP, oops, lost that. And it's now configured on VLAN 101. So if we go into 83.25.3a on 112, we should see the configuration all pre-configured for us. So let's do that. Yeah, so I've just shown running config interface 112, and we now have this VLAN trunk allowed 101. It's been automatically provisioned by the Fabric Composer because it discovered it in vSphere and traced it all the way down to that interface on 83.25.3a. So, are you happy with that, Kamal?
Yes, that was really great seeing that visualization and integration into vSphere. I really got a better handle on that. So just to summarize here, Steve, so what we've set up here is we've discovered our spine and leaf switches and then assigned it to a fabric. We've set up VSX using the guided setup 2, along with our underlay and overlay and EVPN configuration using the guided setup. And lastly, configure our appropriate distributed gateways, which I just learned about on the leaf pair switches. And then finally, we saw this third-party integration, in this case with vSphere, which you just showed us now. So that's really great.
Yeah, and don't forget, we've done all this in a matter of minutes. So admittedly, we've been talking around it, which all takes time. But if we was to do this from scratch, we could probably get it all done in 15 minutes without rushing too much. So you can see how the value of the Fabric Composer helps to deploy spine and leaf networks in an easy to use, simplified way. And this Fabric Composer gives us this validated config time after time. In addition, as you mentioned, we've got the integrations, the HPE Aruba integrations into NetEdit and ILO Amplifier, for example, but we've also got these other integrations into third-party systems like Nutanix and NSXT. And we've seen the vSphere integration, and the Nutanix and NSXT integration will offer the same value, but the components will be called slightly different things, as you can see, but they'll offer the same value and presentation as we've seen with the vSphere integration. So that's it from Kamal and myself, and you've just seen how the Fabric Composer reduces service delivery times in a customer's data center network, and also reduces the complexity of implementation. And it allows administrators with just some networking knowledge to deliver spine and leaf fabrics comprising of BGP, EVPN to support VXLAN extensions. And overall, it simplifies, significantly simplifies operations for admins in the data center, whether they be network admins, VM application owners, or server administrators. So that's it from us, and now handing over to Justin.
Coming up next on the Aruba switching story, we'll hear from Daryl Wan and Steve Baker, two of our data center technical marketing engineers, to discuss how data center bridging can help with our workflow so that the security camera can efficiently access the data center and the facial recognition application and any recording that needs to occur.
bye.